This is video help for problem 15.7. That's actually an old edition number. In the new edition, it's combined and integrated into 15.6. So forget that. If you have the new edition, just do this part. And I've duplicated it here. I've Xeroxed it up here so that you can see exactly what's being asked. So everybody do this problem, please. In part A, we were doing a repeated spin echo thing, and all we needed to know was what the magnetization ended up doing, and that actually had been done before in chapter 8, 8.40, and then in the limit 8.41, and there was problem 8.6, I think, that you did. So you actually know how to do this already. You can just read it off. You don't have to redo this at all. And in the contrast between two tissues, the signals of two tissues, then we have this expression that you just read off of chapter 8, the difference between the two tissues. And in fact, since we're essentially neglecting tau, the time of the echo, so 2 tau is the time of the echo, tau is the time of the pi pulse. You're neglecting tau versus TR. And so this is just 1 minus the same thing as this. So it's 1 minus 2 times the same thing as that. And so it's 1 minus e to the minus TR over T1. And that's just the recovery. Remember our recovery term in the longitudinal polarization is e to the minus T over T1. The recovery at time t, the recovery part of that. That's just that in here for the two tissues. So this is a familiar and not terribly new kind of expression for us. What's different here is that we're looking at the difference between the two. Now, so that part you could just read off without doing anything. Now, if we actually had a spin density weighted image, remember spin density weighted means TR much greater than T1's, T2 certainly, and therefore you get rid of this. See, that's gone, that's 0, and that's 0, and you just have the difference in densities times e to the minus TE over T2A, e to the minus TE over T2B. Well, we're presumably imagining then that the TE would be really small compared to T2, and we would neglect that, and we would just have differences between densities. But when you have a gradient echo, you don't have T2 here. You've got T2 star, and T2 star might be much less than T2. And now you're back having those factors, and what you've got is a signal, both signals, very small in this case, and you end up, having a very difficult time with the gradient echo experiment, and therefore the spin echo is really very much to be preferred.